just a loophole in the system we used to our own advantage. This was, in fact, a strategic move on our parts. It's, after all, a competition. I could feel that this argument was getting worse by the second. And this is where I interrupted and asked them to explain to me what the issue was. So they started. An innovation competition had been going on in the college for some time, where the students had to form the groups to find loopholes in existing technical systems and provide solutions which could be used to protect users against it. Okay, and both Aditi and Suresh had coincidentally decided to work towards same problem. So when they realized that the topics they were working on were the same, and they started accusing each other. So this is when I started laughing. I was looking how passionate both my students were about finding a solution to an issue gripping the whole research community. Maybe many doctoral participants in the list in today's attendee. So maybe they already face this problem. Community of researchers who are working on the same field may choose same topic for their research, right? So this idea could be so obscure for most of the people to understand, and that is why I decided to explain my approach to them. So let us assume Aditi here has in fact stolen your research data. So Suresh, which has negatively impacted your work because your research has essentially been stolen digitally. But how do you prove this? The question is, how do you prove this? So one way to find out conclusively is to check the system users activity logs. Now, the only issue is how you can prove that these logs haven't been changed. If Aditi is in fact the actual culprit, she can very easily get the logs changed to cover her tracks or frame someone else for this. Just think on it. So, based on this, it's very possible that these logs are manipulated to pin the entire blame on Aditi, when in fact she hasn't done anything at all. I hope you understood the problem. Now let me create an imagination in your mind. Now let's talk about solution. Okay. Imagine a box which is made of a material which cannot be broken in any way, no matter how hard you try. Moreover, it has a seal, and anytime you try to open this box, the seal gets a crack, and everyone gets to know that someone tried to break the box. Okay, so the seal acts as a way to notify uh, uh, of the any attempts to tamper with the data. So that this way it will gives us a way to collect proof of any tampering with the data. Okay, and what is the conclusion of the story? The systems, the situations, the processes which are untrusted, and trust is required in such a system, or if you want to build secure and provable systems, we can utilize this type of technology. It is made for this purpose only. Okay, let me go to the second story. Okay, the second story again is very important. Okay, now here you can see there are two people. Okay, assume that Dr. Dhore and Professor Anup Kadam. Okay, now it's examination period, so they are very good friends. So they decided to go to Venice, okay, for a vacation. And so they plan everything. So the flight, the residence, the food, shopping list, everything they plan. And now they are in a position to book the tickets to go to Venice. Okay. Now, coincidentally, they landed on the same portal and they tried to book the tickets. Okay. So this Taiwala guy is Professor Anup Kadam. He has many contacts in the booking sites and booking agents. So he tried it. He talked with various persons and he was able to manage and book the ticket. Okay. On the other side, this Dadiwala guy who's old, who are not aware of about this technology and who has don't have any much contacts in this field. Okay, and that's why somehow he was unable to book the ticket. Okay, now the question is why this Professor Anup Kadam was able to book the ticket and why Dr. Dhore was unable to book the ticket. Okay, so after some time, Dr. Dhore curiously asked what was the reason behind it, how you manage it, how you did that. Okay, so Professor Anup Kadam started explaining. So there is a technology called blockchain which works on various cryptocurrencies. So again, Professor Dhore, Dr. Dhore asked what cryptocurrency is and since when it has been in use. Okay. So again, this Professor Anup Kadam started explaining that this technology initially coined by a group of researchers in 1997. But at that point of time, there were no any special hardwares. And then in 2007 to 9, Santoshi Nakamoto published one white paper on peer-to-peer computing. Okay, and that paper itself talks about the Bitcoin thing, the cryptocurrency thing. Okay, and from that, from 2009 to 13, it got evolved, and this technology came into picture with virtual currency. So, like our normal currency, we can do the day-to-day transactions like buying a shoes, selling something, okay, with the help of this virtual currency, which works on this technology called blockchain. Okay. Now, again, Dr. Dore curiously asks, there were so many systems with me. There were so many apps with me like GPay, PhonePay, Beam, PayPal. I have so many apps through which I can do the transactions. But what is so special in this technology and why you were able to book the ticket? So again, he explained that in normal traditional transaction, there is a middleman who takes your request, process it, and then execute it. Like our day-to-day transactions. So when we use our GPay to transfer some money from user A to user B, the banks, associated banks processes all the requests and responses. Okay. But in the case of blockchain, there is no middleman. It's direct communication between two users. And generally people call it as peer-to-peer communication. And this communication is decentralized in nature. So there is no any central authority to manage these transactions. So again, Dr. Dore say, wow, this is a very good technology to use. And with this, we can stop a lot of frauds and we can get a transparency in the system. So my intention behind putting this story in front of you is the first, the systems, the processes where trust is required, we can utilize this technology. In the second case, the solution of this second story, I'll explain later after few slides so that you will get idea about it. And I am giving you a time to think on it that what are the various reasons could be, and that's why Professor Anup Kadam was able to make that transaction, and Dr. Dore was unable to do that. Okay, you can think on it. We will take a look on it a later point of time. Now, try to understand as I've gone through your syllabus. There are 6 units, and the first 2 units are so basically your syllabus is totally application oriented. So first 2 units and last 2 units are totally application oriented, and in between third and fourth unit is slightly talking about the technology and the construction part of it and the attacks and the security issues. Uh, it's specifically dealing with it. Okay, so what I plan is I try to put a simple animations and examples so that you will understand what this technology is, which is not mentioned even in syllabus. And then I'll take some basic concepts which require to build a blockchain, and then we will go into your actual syllabus, and I'll guide through how you can guide your students for this subject, specific to third and fifth unit. Okay, so let's start. So this blockchain technology is a database. Actually, maybe you have heard the examples of database like MySQL. Okay, so it's similar to that, but the difference between the normal database and this is it is shared across a network of computers. Okay, so blockchain is a database that is shared across a network of computers. Once a record has been added to the chain, it is very difficult to change it. Okay. Now, why and how this technology is so special that no one can modify it or change it, that we are going to see in upcoming slides. So, to ensure all the copies of databases are same and they are not tampered, the network makes constant checks for it. Okay, and with this features, this technology has number of use cases starting from the cryptocurrencies to finance to banking to healthcare, government. There are so many use cases of this emerging technology. Okay, so let's see what this database is, and let's try to understand the building blocks of this technology. Okay, so the very first thing is the record. Okay, so what is record? Record can be anything, any information, any data, any deal, for example. Okay, so for example, I'm sending some money to Professor Pallavi or Dr. Pallavi. Okay, so we can consider this as a transaction, one transaction. Okay, that transaction can be considered as a record. First thing, suppose you have some data on your PC, okay, like photographs, videos, right? That data itself can be considered as a record. Okay, so the record can be anything like information, data, or any deal between the different parties. Okay, now collection of these records, we can call it as a block. So bundle of records will create a block. So now you can see this white box is, we can call a record, and collection of these white boxes. Okay, so you can see there is a lot of collection, and here is a single block, white block we have represented, right? So collection of these records will generate a block. And now if we can link these various blocks with each other, it will create a chain. Okay, and that's how this technology called as blockchain. Sorry. Okay, so all the blocks link together. The crux of the system is how they linked with each other. Okay, that is the important thing. Now let's take a closer look at a single block. Okay, so in every block there are three important things. First is the data. Second is a hash of data. I'll explain what hash is, as you guys are from electronics background. You are going to see what hash is. And then the third is hash of previous block. Okay, so these are the three important parts of a single block. Now let me tell you the trade example of trade. Okay, Now you can see in this picture, yes, yeah. So there are two people, okay? One is Mr. Pink, second is Mr. Green, okay? Now, I hope maybe you have heard this cryptocurrency, okay? Or let's assume these pink are gold coins, okay? Or silver coins. So he wants to sell these two gold coins to Mr. Green for example, 10 lakh rupees. So 5 lakh each coin, okay? So this is a trade between these two guys, okay? So this can be considered as a one record. So this is the example of a record that we have seen in the previous slides. Okay, fine folks. Now, what are the contents in this block? Okay, what are the contents in this record, we can say? Okay, this is a complete block. On that block, there is one record. Okay, and what that record shows. So from Dr. Pallavi to Dr. Sagar, what was the amount? For example, 10 lakh rupees. Okay, so this information we can fetch through this record. Now, the second important aspect and element is hash. Okay, so whatever, so correction of all the records will generate a block, and collectively we can take a hash of it. Okay, so what is a hash? In simple terms, it's a combination of numbers and characters. It's actually a hexadecimal. I hope you have heard about the number systems. So it's actually a hexadecimal number and combination of characters and numbers. Okay, so it will start from 0, combination of 0 from 0 to F. Okay, so 0 to 9 and then again A to F. Okay, so for any type of data, we are going to see the properties of hash, and that's how the importance of hash in this technology. Okay, so it's like a thumbprint. Okay, whenever we will give a thumbprint, maybe you can log in into the systems, right? So it's similar to that. Okay, any modification, okay, any modification in this kind of uh, data, it will generate a complete different hash. So for example, in case of your system login, if someone tries to give his or her thumb, your system will not reply, your system will not respond to that particular guy. Okay, and you'll not be able to log in into the system, right? So what I'm trying to suggest is, see, there are number of hashes available. You can see, okay. So for each record, there is one hash, okay, and collectively we can take a hash of it. And there is a data structure behind this technology who is maintaining all these hashes. Okay, so for example, on the downside, you can see there are 8 transactions. Okay, so this is a transaction 1, 2, 3, 4, 5, 6, 7, 8. Okay, you can consider Dr. Pallavi's and Dr. Sagar's transaction, this transaction. Okay, so this transaction is representing only 1, 2. Okay, so it will be a combination. For representation, I have kept like this, but it will be a 256-bit number, a combination of characters and uh, numbers. Okay, so similarly for every transaction there will be a 256-bit number. Okay, and then on the top for 2, so I hope you have heard binary tree. Like binary tree, we can take hashes of these 2 hashes and we will get this new hash of 256-bit number. With this we will get this, with this we will get this, with this. So you can apply the hashing algorithm to any data and you can generate the 256-bit hash. Okay, we are going to see in upcoming slides how it works. And collectively it goes to root. Okay, finally, so you can see there are 8 transactions we can store only in 256-bit number. Okay, clear? So that is the important thing, right? Just a minute. Just a minute. I have one urgent call. Yeah, sorry for the disturbance. Yeah, coming to the slide. Yeah, so it will generate a Merkle root. Okay, now see, and the third important component and element is the hash of previous block, and that's how it generates the chain of different blocks. Now, how this record? So, see, in the centralized system, there is central authority who knows who is doing the transaction. Okay, let me rephrase that thing so that you will understand how it works. So, say. Here is an example how you can do the transaction and how transaction would take place. So say user A wants to send some money to user B. Okay. So when you transaction information about the sender and receiver is packaged and timestamped on a block and sent to the queue called mempool or memory pool, we generally call it, where it will wait to be validated, and then we can add to the blockchain. Okay, simple. Now here you can see in this animation, this record will go into the network will check, and the network will accept this record. Now this record is correct for all the nodes. Okay, with all the nodes it is correct, right? Just a minute. Oh, so sorry. It was an important call from management. Okay, let's move. Okay, so that record will get. I hope I'm audible. Can someone confirm, ma'am?
Yes, sir.
Okay. So how we can add this record onto the block? Okay, so you can see. So this is a single record we are adding onto the block, and the collection of these records will generate a complete block. And there are two things that we have seen for a single block. Okay, there will be a hash of this whole block, okay, and hash of a previous block, and that's how the block of records is ready to be added to the chain. Okay, so this is a single block, you can see, right? Now how we can add, how generally this block we can add onto the chain, right? You can see there are three important things. Now you have a new block on which there is a record, okay, hash of this whole block and hash of the previous block. Okay, now we are adding into the chain. So you can see if these two hashes are matching the previous block hash and the upcoming block hash, it will create a chain. Okay, like this. So collection of blocks. So here you can see a simple record. Collection of records will be block, and collection of these blocks linked together with cryptographic techniques is called the chain, and completely as a whole it called as a blockchain. Right now, try to see the important properties of this basic concepts. Okay, this is very important, that's why I'm trying to spend a lot of time on this, and maybe after that we will take it fastly, right? So what is hash? Okay, so right now I'm just trying to tweet a very small statement called just setting up my Twitter account. So here you can see 1, 2, 3, 4, 5. There are only 5 words, right? So if I can take a hash of these 5 words, it will generate the 256-bit number. So what hash is? Hash is a mathematical function which takes any amount of data as an input but generate only fixed length of string like 256-bit. Depends on the algorithm. Okay, so your SHA-256 will generate a 256-bit, or we can say the 32-byte hash length, right? Very simple. Now you can see, let me give you another example. Okay, so this example is of War and Peace. I hope you have read this book. This is very interesting book of around 300 to 400 pages. Okay, now, and assume that this is digital in nature, and I'm taking hash of it. Okay, so if I'm going to take a hash of it, it will again generate the 256-bit number, which is a combination of numbers and characters, right? So think on it. For previous case, it was just 5 characters, okay, 5 words, and here it's bunch of characters around in lakhs, right? Still, it is generating a 256-bit number. So that is the beauty of this hashing algorithm. Okay, that is the one property. Second, if I can make any modification, like here I try to remove some part with red remark. Okay, any modification into the data will generate a complete different hash. Okay, so here you can see the previous book hash is of 256-bit number, and I tried to modify very slightly. Okay, so you can see the number. So you can compare these two numbers. They are very different, very different. So this is the second property, and generally people call this avalanche effect. Any modification in the data will generate a complete different hash. Okay, that is the second property. The third property is we cannot regenerate the data from the hash. Okay, we cannot regenerate the actual content from the hash. By looking at the hash, we cannot generate it. That is the third important property. Okay, so these three are very important properties of any hashing algorithm. And let's see how anyone can break the chain. Okay, generally it not happen, but for understanding, let's see how it works. So assume that Mr. Green, initial deal, Mr. Green is trying to secretly change the data. Okay, so he's trying to give only 5 lakhs instead of 10 lakhs, which was decided. Okay, so what will happen here? Let me stop here. What will happen if I try to modify anything in this record? Okay, it will with that Merkle tree. Okay, with that Merkle tree, it will completely change the hash of the block. Okay, with the property of hash, any small modification in the data, will completely generate a new hash, and again combinedly this block hash will get changed, which will not match with the previous hash, and finally this block will not get accepted into the chain. Okay, which actually breaks the chain, break the connection, and will loss from that. Okay, and recalculating for forge and attackers, it's very difficult to recalculate the hashes of all the previous blocks because the chain has been grown already a lot. Okay, this is a simple illustration of that. Let's see. So there are three blocks in this case. Okay, first, second, and third. Okay, the very first one is green. Okay, and as it is a very first block of any blockchain, okay, it is called as a genesis block, okay, in the system. Now we talked about three things. Single block consists data, second, hash of data. So assume that this is a 256-bit number. For representation I have given like this, okay, and hash of a previous block, that is third element. So right now there is no previous block, as it is the first block, the previous hash will be 0000. Okay, now come to the second block, data, then hash of data is 6bq1 and the hash of the previous block. Okay, so what is the hash of the previous block? You can see hash of the previous block is 1z8f. Correct. Now come to the third one. Now you have a third red guy. So if you can take a hash of this, it will be 3h4q. And the third element, what is the previous block for this third? There is a second. Okay, so what is the hash of second? Second will be 6bq1. Okay, so it will take that. So this is the representation of. Now assume that someone is trying to tamper the second block, someone is trying to change the deal between the second in the second block, like that Mr. Green change, right? So here what will happen if any malicious attacker will change the record, any record of this block will change the complete hash from 6bq1 to h62y, anything small modification, and then at the time of third block creation it will not match with the previous one, because the third one is taking the previous block hash, which was 6bq1 initially, and then third will say, oh, that's not right and we should not consider this second, right? That's how it will got to know to the network that something has happened. Okay, this is for only representation. In real, it will not happen. Okay, as it takes the validation and consensus mechanism to make it. For representation, I'm just showing you. Okay, now let's take a look at the demo of this technology. Okay, so there is one very popular demo of blockchain called Anders Bronworth. Okay, so let me go to, just a minute. I'll show you the demo. Blockchain demo. Yeah, can you see my browser? Yes, no? Can anyone confirm? Ma'am, are you there? Yeah, I think it's visible.
Yes, sir.
I can see from my, okay, great. So here you can see the blockchain demo. You can just Google it out, Anders demo on the blockchain technology. Okay. So right now you have this data field, and I'm showing the example of hash, how hash, how we can generate a hash. Okay, so right now I'm giving my name Sagar, Sagar. So you can see on the bottom side, it is generating a 256-bit number. So what this algorithm is doing, it's actually a mathematical function who is taking some data as an input. That data may be 1 MB, 2 MB, 1 GB, anything. Okay, and the output is fixed. Okay, so you can see for any number of data, it is generating a fixed length of string. That is the first thing. Second, any small modification. Okay, so suppose here I am trying to remove E from running. Okay, E, it will change completely. Okay, so any small modification will generate a drastic effect called avalanche effect into the hash, right? That is the third thing. Now by analyzing this hash, you cannot generate the data. Okay, that is there. Okay, so these are three important properties of hash. Now let's see the demo of block, how your block look like. So there is a block number, there is a nonce for each block. Nonce means number only used once. So throughout the blockchain, that number will use only once. Okay, then your data and your hash. So this is the representation of your single block, right? When we create a chain of it, it will take a hash of a previous block as well, that we are going to see in the blockchain demo, right? So again, whatever I am writing, it will get captured and it generates the hash of it. Now we will come back to this mining part in further slides, but I'll show you how it works. So whenever you will click, okay, it takes some time to validate this transaction, that this transaction is real and correct. Okay, and that is the job of mining process. We'll come to that part later. But for now, try to understand. Now these are the important aspect, like block number, number only used once, data, and see, these nonce are not in a sequence. Okay, always that is not the case. Okay, and you can put any type of data into this. Okay, right now for understanding, you can see it's a placeholder where I can put the strings. Okay, but in real you can take any type of data into this, like your photographs, jpg files, videos, mp4 files, anything, and it will generate a hash. Okay, now coming to the third point. The third point is the chain of blocks. So this is my block 1, this is my block 2, this is my block 3. Okay, so you can see the nonce file. So here you can see it's 11,316. Then again you can see 35,230, and the third one is again 12,937. So it's number only used once, which actually require in the mining process that we are going to see in further slides. Okay, and then your data. So whatever data you will put into this box will generate a hash of it. Okay, so right now there is no any data, it takes hash of this space. Okay, you can see this is the hash. What is the previous hash of this block? There is no previous block to this first block, that's why it is taking all zeros. Okay, clear? Now coming to the second. Okay, second block, whatever information I have, it is taking hash of it, and the third element is it is taking hash of the previous block. So what is the hash of previous block? You can see it is starting from 0000 and then 15, so it is taking the same. So if you match these two hashes will match. Okay, and coming to the third part, if you come to the third block, again you have a data, you can take a hash of it. Okay, hash of the previous block. So 000012 and 0001, right? Similarly, the chain will grow. Now any modification in between will completely change the hash. So right now this application is changing everything, right? So whenever I'm changing here, it will change hash of it, and it is taking care of hash into this block as well. Okay, but generally it will not happen. Okay, and that's how it will a network will get information about this manipulated or tampered block. Okay, that is the explanation. Now, in distributed environment as well, it will work as it's called as a decentralized what we can say systems like peer A. There is a peer A. For peer A, there are number of blocks. For peer B, there are number of blocks. For peer C, there are number of blocks, and they can communicate with each other. Okay, so this is the example and the short demo of what we can say blockchain hash block and the blockchain how it works. Okay, right. Now let's move ahead and try to understand the types of network. Okay, there are two types of networks that are available: the centralized one and the decentralized one. So in centralized, in our normal traditional systems, we are using centralized network. Okay, where there is a one admin who is taking care of the request of all the clients. It works like client server architecture. So there is a one server, the big server in yellow color you can see. Okay, and here on blue side there are all clients who are requesting this server for anything, and this server will respond to all the clients. So it works in that fashion. Okay, on the other side, if you can see, in decentralized network, every node has authority. Okay, so as the name suggests, you can see decentralized. Okay, making a decentralized, we are giving all the authorities to each and every node. Okay, in this kind of system. So here this blue is a one node, and there are collection of nodes which are connected with each other. Okay, and if anyone wants to request something, okay, he will initiate the request to nearest node and all. Okay, so this is how it works, right? Now, the very important part and the heart of the blockchain system is called mining. Okay, so let me till this let me recap the whole scenario so that you will understand what's happening here and collectively how it works. So let's go back to our previous transaction. Okay, so say user A wants to send some data or money to user B. So when user A initiates a transaction, okay, when user A initiates a transaction, information about the sender and receiver is packaged and timestamped on a block, and then it's sent to a queue called memory pool. Okay, and after that, then the transaction will get validated and will get added onto the blockchain. So that validation process comes with this mining. I hope you have heard this mining word uh, in Marathi when we talked about all the khanije, right? The tail system, right? So the miners that have successfully discovered blocks will take batches of transaction and verify that all of the information, including digital signatures, messages, and the public keys, are legitimate. In short, all the information and transaction is correct. In simple words, once the information is verified, the block is broadcast to all the nodes in the network, who must check and agree that the block is valid before adding that block to the chain. And the average time it takes to confirm for Bitcoin, it's around 7 to 10 minutes. Okay, when this whole process gets complete, user B will receive some money. Okay, all nodes on the network will have agreed to the transaction using the chosen consensus model. Okay, and then will have earn reward. Okay, after verifying the transaction, right? So that is the job of mining. Okay, so mining process actually what does, it verifies your transaction. Okay, in short, in simpler way. Now there is a number system. I hope everyone is aware about this hexadecimal number system. Like decimal, there is a hexadecimal, and this hashing works with hexadecimal. Okay, so hash is just a number. Now, how this mining process works? Let me tell you. So on the pool of hashes, you can say there are all zeros. Like the starting block, we have already seen all zeros were there. Okay, all 256 will be zero, and this largest number will be all f. Okay, right now the system will give you a target. Okay, target of any hash value. So that target may be in the range from smallest to largest. Okay, now in this case, whatever you are looking on the slide, on the downside we have set the target, and that's why you can see the green area here. So now what is there in my block, how your block gets validated and how mining process works, let me explain you that. So there is a block, so it's a third number block. No, the nonce of block is 23. The data uh, of this block is world, for example, and hash of this previous hash of this block, the previous hash of this block is this, and hash of this block is this. Now whenever you will get a target from the system, that you have to fall under this. So we have seen the green area, it's a downside area. So now I can change, I can change this nonce. Okay, so right now I'm changing nonce to 23, but and it is pointing the hash. So whenever I'm changing 23, it is giving me this hash, and it is pointing to this area. So from this range to this. Okay, so that is not our target, right? Now come to the second. Now I change nonce to the 20. I guess that its 23 number is placing here, so I tried with 20. Okay, in general it will not happen, but I tried 20, and then again I'll get a new hash. Again it is pointing to the largest pool, largest side, upper side. Okay, so I'll not consider this as well. Now third, in third what I'm doing, I change to 700. Okay, it's 700, it's a mistake, right? 700, and now I'm getting hash which is falling under my target. So I set this target, and it is falling under my target. Okay, it is giving me a hash in between smallest to this middle area. And after getting this, so why I'm showing this you as an example. So we have seen only three cases, trial and error. So like this, your system will give you cryptographic puzzles which are very computationally intensive and time taking. Okay, they will take a lot of time to solve this puzzle. Okay, and to change these nonce numbers and try to match with the target. Okay, and that's how the mining process will work. Okay, so in the network there are multiple people involved, multiple nodes involved, who are coming to do the mining process. Why they are doing that? Because after mining a successful block, that means after guessing a successful hash, they will get a reward. Reward means in terms of money, in terms of cryptocurrency. And that's how whole system will participate in this mining process. Okay, so the people, those who are have those who are having high computational capabilities, they will easily change these nonce very frequently and try to match the targeted hash. If they will get it, they will validate the block. That is called the validation of a block. That means the cryptographic puzzle is solved, and you are getting the targeted hash, and thus you will get the rewards. Right? Clear? Now, like people like us. Okay, again, while coming back to the mining process, let me tell you that mining is illegal in India. Again, I am repeating, mining is illegal in India. We cannot do mining in India, blockchain mining. Huh? The data mining and all is completely different story. We cannot do that. Otherwise, you will behind the bars, right? Yes, we can utilize cryptocurrency and all, but we cannot do mining. It's banned in India. Okay, so we have very, so the people who has very limited computational capabilities, okay, uh, will come together. Okay, suppose I have a 8 GB RAM laptop, my friend is having 8 GB laptop. We can come together, we can join our laptop somehow. We will make 16 GB RAM and we will try to take these blocks to mine, and through this we will get the rewards. Okay, and then again, uh, depending on the computational capability, we will share the rewards. Okay, so it's my friend's RAM will be 8 GB, then he will get the 50% share, I'll get the 50%. That is the uh, one type of area is happening in the pool mine, okay, in the blockchain systems. Now after validating the block, after validation of any block, there is a consensus models that are available in the system. Okay, consensus means agreements between different parties. That means your block is validated now. Now this block will shared with all the users that are there in the system. Okay, and they will get a complete copy, clear copy of all the records. So here you can see there are 6 people. All people will get a complete copy of a ledger with them. Okay, so if someone tries to modify this copy, her copy for example, it will not match with him, it will not match with him, it will not match with her. Okay, so there are some consensus mechanism algorithms that are available to do that, and thus this mining and consensus will work hand in hand, and then they will generate a very good type of systems, right? So there are consensus algorithms that are available. You can see proof of work and proof of stake. There are many actually, proof of activity, proof of elapsed time. There are so many parameters based on these algorithm works. The very popular are two, proof of work and proof of stake. Okay, so now you can see the picture. Okay, so people are coming into the system, they are becoming a node, they are trying to do the mining process, and they are earning the rewards. Okay, so who, there should be some algorithms, or there should be some criteria who can participate in the mining process. Okay, so, and who will get new blocks to mine every time. Okay, that is the big question. So group of researchers form a very good algorithm called proof of work. Okay, as the name suggests, those who will work hard and show their results, or they will mine their blocks in a very short period of time, they will get a new blocks to mine. Okay, once they will get a new blocks, again there are chances of high chances that they will mine the block and they will earn the rewards. So that is the criteria one. So those who will work hard, they will show their results. Those who will mine their blocks will earn the money. Okay, and they will get a new blocks to mine. On the other hand, in proof of stake, okay, so those who have a very good stake, stake means money, cryptocurrency in the market, okay, they will get a new job. So think like, it's unofficial that some of the people in the government, for example Ambani and Adani, they are getting a good contracts, big contracts, because they have handsome amount of money in their hand. We can say they have a good stake in the market, so that they can get a new blocks to mine. Okay, and of course after mining they will get the rewards. So these are the two popular algorithms that are available for mining in blockchain kind of system. Okay, so I think as per suggestions of coordinator, we should take a small break, maybe 5 minutes or 10 minutes. Yes, ma'am. Are you there? And then after that, we will again continue our second half, where I'll actually go through the syllabus. So most of the concepts are I already tried to cover in my previous talk. in the first half, and then we will